Hello class, this is Mr. Hart, and in this podcast we're going to start our unit on polynomials and factoring. And in this lesson we're just going to focus on an introduction to polynomials, what they are, how we kind of work with them, and that type of thing. Okay, so first of all, let's just understand what a polynomial is. Okay, so you want to ask, what is a polynomial? Okay, and so it often looks like this. Okay, we got a bunch of different x's or y's, right? Some variable, some power signs, some coefficients, numbers times in front, right? So it's just kind of this expression with things added together or minus from each other. Okay, but if you want to be very particular, okay, a polynomial is an expression with multiple powers of a variable, of the same variable. Okay, so notice this expression has an x cubed and an x to the first. Okay, so we have not only the cubic power, but we got this x to the first, right? We could write a 1 there if we want to be clear. Okay, and then we got a constant in there as well, right? So we got a constant and x to the first power and x to the third power. We got a lot of the same variable but to different powers. Okay, so it could have an x squared as well, right? So a polynomial is just some expression that has the same variable listed multiple times but with different powers. Okay, so again, we could keep building off this. It could have a 3x to the 6th power in front. It could add a square power in there. Anything as long as it's x to some power, okay, or whatever the variable is, that's a polynomial. Okay, and so there's a lot of things we can do with polynomials, but first we need to do some just basic vocabulary when we're trying to describe what a polynomial is. Okay, so there's 3 common words we'll use when we're trying to describe a polynomial. Okay, so those 3 words are term, degree, and leading coefficient. Okay, so a term in a polynomial is any part of the polynomial that is separated by a plus or minus sign. Okay, so for example, let's say we had 6x to the third plus 2x squared. Okay, so in this case 6x cubed would be a term and 2x squared would be a term because they are separated by a plus sign in this case. Okay, so a term is just anything separated by a plus or minus sign. Okay, the degree is the highest power term in the polynomial. Okay, so we look at all the powers in the polynomial and we look for the highest one. In this case 3 would be the highest one, so it would be the degree. So in this case 3 would be the degree of the polynomial. Okay, and then the leading coefficient is the number in front of the highest power term. So 3 was the highest power term, 6 is the largest, or the number in front of it. Okay, so the leading coefficient would be 6 in this case. Okay, so we use these words a lot when we're trying to describe polynomials. We'll use them when we're trying to describe methods with factoring and things like that. So we need to know what a term is, what a degree is, and what the leading coefficient is. Okay, let's go back to our previous example. Okay, 5x cubed plus 7x plus 2. Okay, so in this case, let's identify all the terms. So again, the term is anything separated by a plus or minus sign. So 5x cubed would be a term, 7x would be a term, and 2 would be a term. Okay, they're all separated by these plus signs. Okay, so now if we're trying to find the degree, we look for the highest power, and again, it's going to be this cubed right here. Okay, so the degree is going to be 3. Okay, and the leading coefficient is the number in front of the term with the highest power. So that's going to be this 5 right here. So let me do that in green, for example. So that 5 is leading coefficient. So the leading coefficient is 3. Okay, or sorry, 5. So 5 is the largest, or the number in front of the largest power, or the degree, so it is 5. Okay, so these are the terms. The degree is 3, and the leading coefficient is 5. Okay, so pretty simple, but we just want to make sure we're clear on what we're talking about when we're describing polynomials. Okay, Next, we want to talk about how we actually name polynomials. Okay, and so we give kind of names to polynomials to help us kind of distinguish between certain types. Okay, and it's really simple. All you do is if you want to name the number or name the polynomial, you just have to count the number of terms. Okay, so in this case we had 3 terms, so this would be a trinomial. Okay, so there's kind of this table or this idea of giving a prefix based on the number of terms. Okay, so if there's only one term in your expression, then the normal prefix for that type of thing is mono. Okay, mono means one, like a mono sound system, if you've ever heard of that. So this would become a monomial. Okay, if you only have 2 terms in the expression, then the prefix for 2 is bi, like bi-weekly. Okay, someone gets paid bi-weekly, they get paid every 2 weeks. Okay, and that is going to be a binomial. Okay, for 3 will be trinomial. For 4 is quadrinomial, and then 5 is penta, so pentanomial. Okay, so this is for the number of terms. That's one way of naming the polynomial. You'll also see it be named by the degree. Okay, and that's a slightly different naming system. You may have heard of like a quadratic equation or a cubic equation. So a quadratic equation has a squared term. A cubic equation has a term to the 3rd power. Okay, a 3. So you may also see that naming system as well. Okay, but for my class, we'll just focus on the term naming system. So we're going to name them based on the number of terms. Okay? All right. So I'd write down this table if you could, so you know these different prefixes that you're going to need. Okay? But let's go ahead and try an example problem. Okay? So identify the number of terms, the degree, the leading coefficient, and then name the polynomial. Okay? So we have this expression 7 plus 4a plus 6a squared minus 5a cubed. Okay? So we got 1, 2, 3, 4 terms. Okay? So the number of terms is going to be 4. So we got 4 terms. Okay? The degree is going to be the highest power, which is again this 3 over here. So the degree is also going to be 3 again. So degree is 3. Leading coefficient is the term or the number in front of that highest power term, which is this 5. Okay, so the leading coefficient again is 5. And then last of all, let's name the polynomial. So naming the polynomial, again, we're going to focus on the number of terms. So we got 4 terms in this case. So if we go back to our table, we'd see that's the quad prefix. So this is a quadrinomial. Quadrinomial. Okay. And there we go. So we have identified all the different parts of this polynomial. Okay. All right, so there's one last thing we'd like to do, okay, with just rearranging polynomials. And we want to make sure that the leading coefficient is actually in the lead, right? We want it to be in front. Okay, you'll notice that this doesn't look like our other examples because this highest power is on the very far right side. Usually polynomials are written in terms of their highest power being first and their lowest power being last, or the constant being last. Okay, so this is not in standard form as we say it. Okay, so if you want to write something in standard form, we need to have the largest power first. Okay, so it is a common practice to put every polynomial in standard form. Okay, this means that the highest power term goes in front, then the next highest power comes next, and so on until you get to the last term. Okay, so this is what we had before, right? This is non-standard form. This is the highest power, the 5a cubed. So it should be in front, okay, not on the very back. Okay, so we're going to put the 5a cubed in front. Then we'll find the next highest power term, which is 6a squared. We'll put that next. Then the 4a is the next highest power term. We'll put that next. And then the 7 is last. Okay, so this is standard form, okay, whereas the other one was not. Okay, so that's the last thing is if you ever see a polynomial, you want to write it in standard form if you can. Okay? All right, let's try one more example with this and then we'll move on. Okay, so put the following polynomial in standard form, then identify the number of terms, the degree, the leading coefficient, and name the polynomial. Okay? So we won't focus too much on the other parts since we already did it, but let's look at how we put this in standard form. Okay? So we want to make sure the highest power term is in front. Okay, and if you look through, this 6 is the highest power term, right? So the 8n squared, or sorry, 8n to the 6th should be in front. Okay, and then we look for the next highest power term. Okay, that's this cubed right here. So plus 5n cubed. Okay, then it looks like the squared is next, so minus 10n squared minus n, and then minus 1. Okay, so there we go. There's standard form from highest power to lowest power. Okay, that's what the polynomial should be written as. Okay, then the other parts are really easy. So the number of terms would be 1, 2, 3, 4, 5 terms. Okay, the degree would be the 6th power. The leading coefficient would be the 8. And the name of the polynomial would be, let's see, we got 5 terms, so pentanomial. This would be a pentanomial. Okay? All right, so there we go. Pretty easy. Let's move on. Okay, so that's all the stuff with just kind of understanding what the polynomial is and how we write it down. Let's just do some very basic operations with polynomials. Okay, so let's do adding and subtracting with polynomials. Okay, so when we're simplifying expressions and we're adding and subtracting, it's important that you only add and subtract like terms. Okay, so you probably have learned this before, you know, with x and y, for example. You can't add x and y and get a simpler expression, right? It just doesn't work. It's like adding apples and oranges. You have to add like terms, okay? Now with polynomials, it's the same idea, okay? But like terms in this case is going to be things with the same power, okay? So for example, if I have an x cubed and a x, I can't add those together because they don't have the same power. Even though they're both x, they do not have the same power, so they are not like terms. You cannot combine them. Okay, so you only focus on like terms, okay, when you are simplifying expressions. Okay? So, for example, let's say we're trying to simplify the expression minus 8x to the 4th minus 5 plus minus 3x to the 4th plus 3. Okay. So first of all, let's just get rid of these parentheses. Okay, when we're adding stuff, we really don't need these parentheses. Okay, so I'm just going to rewrite it like this without the parentheses. Okay, and then we want to focus on like terms. So we got constants, 5 and 3, and we got x to the 4th. Okay, now obviously we can't add the constants and the fourth, or the constants and the 4th powers together. Okay, so let's bring this minus 8 and this minus 3 together. That's going to give us minus 11x to the 4th. And this minus 5 and that plus 3 is going to give us minus 2. Okay? So, again, we can kind of think of, well, these guys are like terms right here. And these guys are like terms right there. So we can combine the negative 5 and the 3. We can combine the negative 8x to the 4th and the negative 3x to the 4th, but we cannot combine them together because they are not like terms. Okay? So if we simplify this expression, this is what we end up with. Okay? So pretty simple. You just add the terms that are the same power and you're good to go. Okay? Let's try one more. Just make sure we got this down. Okay, so 6r cubed minus r minus negative 4r plus 6r squared plus 3r squared. Okay, so let's see what we can do. So kind of a long expression, but first of all, let's take care of this minus sign right here. Okay, so because this is a minus sign, there is one extra step you gotta do. Okay, and before I just got rid of the parentheses, but it's really important that you distribute this minus sign to each term first before you continue the expression. Okay? So, or continue simplifying the expression, I should say. So that minus sign is going to turn this into a plus, that into a minus, and that into a minus. Okay? So let's rewrite it now without the parentheses. So 6r cubed minus r plus 4r minus 6r squared minus 3r squared. Okay? All right, so let's look for like terms. So it looks like this r and that r are like terms, and this 6r squared and that 3r squared are like terms. Okay? So we're going to get 6r cubed. That minus r and 4r are going to give us 3r. And this 6r squared and this minus 3r squared are going to give us minus 9r squared. Okay? So there we go. That's our final expression. Okay, but there's one more thing we like to do. Again, we usually like to write it in standard form. So I'm going to switch this 9r squared over there and that 3r over there. Okay. So let's rewrite this really quickly as minus 9r squared plus 3r. Okay. And there we go. So that is now our simplified expression in standard form. Okay, 6r cubed minus 9r squared plus 3r. Okay? All right, so that's one thing you're going to be doing on your homework is just simplifying some very basic expressions. Okay? And then last of all, we want to learn how to multiply with expressions. Okay? Now, multiplying expressions is a little bit trickier. It's not too bad. You just have to keep in mind there's a couple of extra steps. Okay, but let's just look at this example. Okay, so find the product basically means just multiply them together. Okay, so we have 5x times 2x minus 6. Okay, so when we multiply these guys, we're going to have to multiply to both parts of this expression, right? Just like if this was 5, not 5x, right? You'd have to distribute. So even if this is still an expression or a polynomial, still got to distribute through to each one. Okay, so we're going to get 5x times 2x minus 5x times 6. Okay, or I could have written it like this, plus 5x times negative 6. Okay, so you distribute to both and then you just simplify. Okay, so 5 times 2 is 10. X times x is x squared. Plus 5 times negative 6 is negative 30. And then x times 1 is x. Okay, so there you go. There's our expression. So 10x squared minus 30x. Okay, so pretty simple. You're just multiplying through and you have your answer. Okay, let's try one more to make sure we got this down. So 2m times 7m minus 7. Okay, again, we're going to distribute that through. So we get 2m times 7m and 2m times negative 7. So we're going to get 2m times 7m plus 2m times negative 7. Okay. So that gives us 2 times 7 is 14. M times m is m squared. Plus 2 times negative 7 is negative 14. M times 1 is m. Okay? All right, and there you go. There's our product. Okay? All right, last of all, let's do one more example. So right now we've been doing one polynomial expression, or sorry, a monomial, right? One variable times a expression on the inside. Okay, let's do a more complicated example where we got an expression on both cases. Okay. Now you may have learned this in a previous math class. Some people say, "Oh, we got to FOIL this." Okay. Now there's two ways to think about it. You can just either distribute twice or you can FOIL. Either one is fine. Okay. But let's just look at the distribution method first. Okay. So now if we treat this as one expression, right, one thing we have to distribute, we're going to have to distribute this whole thing to the p and the minus 6. Okay? So if we do that, we're going to get 6p plus 5 times p, and we're going to get 6p plus 5 times negative 6. Okay? Then we could distribute again and say, okay, now we got to distribute the p to both the 5 and the 6p, and we have to distribute the negative 6 to the 5 and the 6p. So that would give, on this expression, that would give 6p times p plus 5 times p plus 6p times negative 6 plus 5 times negative 6. Okay? So, as you can see, we can kind of do this method of double distributing. Okay? We just have to times basically everything by everything else, pretty much. Okay? But you'll notice we end up with 4 terms. Okay? 6p times p, 5p, 6p times negative 6, and 5 times negative 6. Okay? And so you could simplify all of this, okay, and you just can always do the double distribute. But again, some people have come up with this other method of what they call FOIL. So these 4 terms that you see here end up being what we call the FOIL terms, okay? And so some people write it like this, okay? So if I times the 6p and the p, those are the 2 first terms of the expression, which would give f, okay? And then if we times the outer 2 terms on the outside, these are O outside, okay? And then these 2 terms are the inside, and these 2 terms are the last, okay? So that's what FOIL stands for, okay? So first, outside, or outer, inside, and last. Okay, so that's where it comes from. Okay, but you'll notice if we do this multiplication, okay, we look at these terms, we'll get those exact same 4 terms we had below. Okay, so we'll get 6p times p is our first multiplication, so 6p times p. Our outside is 6p and negative 6. Okay, so 6p times negative 6. Okay, our inside terms are 5 times p, and our last terms are 5 times negative 6. Okay, so notice we got the exact same expression as we had before. Okay, so point is, you can do it either way. You can do the double distribution like I was showing first, or you can do a FOIL method basically. So you just identify the 4 terms that you're going to need, and you just list them out. Okay. So either way, double distribute or FOIL. Okay. All right, so let's finish off this problem now. Okay. So this will give us 6p times p will give us 6p squared. 6p times negative 6 will give us negative 36p. 5 times p will just give us 5p. And 5 times negative 6 will give us negative 30. Okay. So we could leave the expression like this, but we can simplify a little bit more because we can combine this 36p and this 5p. Okay. So if we combine those two, negative 36p plus 5p, we get minus 31p. Okay. So there we go. So if we wrote this out fully simplified and everything, we just get 6p squared minus 31p minus 30. Okay, and there's our answer. Okay. All right, so I know that's a lot of stuff we've covered for today. Let's just quickly review everything we've talked about. So the first thing we talked about was identifying the parts of a polynomial, okay, writing in standard form, and naming the polynomial. Okay. Then we talked about adding and subtracting, okay, and just adding the like terms, and looking at where you can add and where you cannot, right? Just grouping by the different powers basically and looking for like terms. Okay, and the last thing we did was multiplying. Okay, and we looked at both the distribution method for single terms, okay, and then more commonly FOIL method for two terms. Okay, so there we go. So identifying and naming, we talked about adding polynomials and multiplying and distributing. Okay, but there we go. So that's a lot of ground to cover, but it will give us a good foundation for when we want to do factoring. Okay, all right, but hopefully that all made sense. Let me know if you have any questions, and thank you for watching.